This is our example number 4 in the parallel circuits. So we've identified our parallel, and this time what we're trying to figure out is how much amperage we have. So let's go ahead and fill in our known values. We've got 12 volts here, and we know what our resistor values are. We only have 3, so that's 8 ohms, 8 ohms, and 4 ohms. We don't know what our amperage is, and so now what we can do is we can fill in some more blanks by using circuit laws. We know in a parallel circuit that all the voltage is going to be the same. It's all constant. So 12 volts, 12 volts, 12 volts. Okay. So now all we have to do is some Ohm's law so that we can figure out what our amperage total is, and then we can double check ourselves. So if we use Ohm's law, we can start here at the bottom. 12 divided by 4 is 3, and 12 divided by 8 is going to be, I'm not a huge math whiz, so I'm going to bust out my calculator here real quick. So 12 divided by 8 gives us 1.5, and that's the same over here. Okay, so now what we can do is we can add this up to get our amperage total. So 1.5 and 1.5 is 3. 3 plus 3 is 6 amps. So now if we calculate our amperage and our voltage, we can figure out what our resistance total is. And that way we can see if we're correct, because this is the answer we were actually looking for, is 6 amps. So 12 divided by 6 is 2. That would be resistance total. So let's see if we're correct. Voltage is constant in a parallel circuit, so that's got to be correct. Amperage is additive. 1.5, 1.5 plus 3, that's equals 6 amps. So if we add up our resistance, we can do the same thing. Now remember, in a parallel circuit, resistance is additive, but it's added with a reciprocal sum. So we have 2 resistors here that are 8 ohms. So we have an 8 ohm resistor divided by 2 of them, and that equals 4. So now we reduced those 2 down to 4. And we have another resistor 4, so that we got 4 divided by 2 equals 2. And so this would be our resistance total, which is exactly what we have. So we know we did that right.